My name's Adam Paul, and I'm a recent graduate from the University of Hartford Acoustics program. My specific degree was in acoustical engineering and music, and my music concentration at the Hart School was vocal performance.
My name is David Arena. I'm also a graduate of the University of Hartford Acoustics program. My major was mechanical engineering with a concentration in acoustics.
And the Paul S. Vanek-Clausen Research Foundation sponsored hospital noise floor test was our senior capstone research project. So regarding the types of sound that we expected in a hospital setting, we have airborne noise and we also have surface-generated noise. And we use three main tests to characterize the performance of these materials within those categories. We started with ASTM C423, which is our absorption testing standard, and we used that to get the absorption coefficients of the materials for our airborne noise. And then as far as our surface-generated noise, we used ISO 3741, which is our sound power test. And for that, you can change your sound sources. And so we chose a tapping machine for impact noise to sort of simulate footfalls and different walking and running down a hallway. And we also chose a reciprocating cart, a machine that would roll a hospital cart back and forth to simulate medicine carts and gurneys and stretchers rolling down the hallway.
So one might think that the obvious choice for blocking out any sort of noise from a hallway would be just closing the patient room door. Unfortunately, in a hospital, that's not really a viable option. There's a lot of buzzers and alarms that need to be heard from nurses around the corners and everything like that. And if there were ever an emergency, it would really be a hindrance to have the door closed. So really, the door has to remain open, which just creates an absolutely open path for any sound to travel in. In the acoustics world, we really look at just kind of when we're looking at any sort of design example, we look at source, path, receiver. So now we have the receiver, which is the hospital patient, and we can't just stick earplugs on them and call it a day. What we have to really do is look at the path, and since we can't close the hospital door, we have to really look at the source, which is why we're putting such a focus on these surface-generated sounds from the rolling hospital carts and from footfall traffic. I think we had expectations about how the carpet would perform, but in terms of hospital settings, we knew that carpet wasn't really a viable option, just because it's really difficult to disinfect. So we were both really, really excited to kind of find out how these vinyl floors would behave in terms of kind of this gold standard that most people use in a hospital setting, which is carpet. So we wanted to see how they would perform.
We really were blown away by the performance of the rubber-backed samples when it's compared to carpet. You really can't mop up different things that you'd find in a hospital off of a carpet. So this sort of easily disinfectable material and that performs as close to carpet, it's a good option.
Absolutely. When we were actually testing the floors, we tested in a certified reverberation chamber that we had at the school. So when we laid out we had these large 72-foot square foot sections of the floor that we conducted the tests on. And when we had an unbacked sample versus a backed sample, the difference was absolutely night and day. When we had the backing on the floor, it really did a great job of attenuating a lot of the lower frequencies, and it kind of took out just a lot of the harsher sounds, and it was a very, very noticeable difference. Even without looking at the data, we were just able to hear the difference very.
Absolutely. We saw really similar performance between the rubber-backed vinyl and the rubber-backed carpet. I believe there's a published report where people can take a look at the specific graphs and everything like that, so you can really see for yourself the lines, they match up. It's pretty wild.